Actually, in the ArcMap software, there's actually um, in the ArcMap software, there's actually an ArcMap suite called ArcMap Scene. So if I just search it on my desktop, so just search on your desktop ArcMap Scene. So mine is loading on the other screen, so just waiting for it to load. So basically, ArcMap Scene or ArcGIS or ArcScene is basically a software of ArcMap that enables you to carry out simulations in regards to flooding and even landslides. So in the second part, I'm going to show you how actually ArcMap Scene actually works. It's not actual requirement for this particular assignment, but just to give you a bit of a visualization aspect in regards to of how the digital elevation model can be projected if it had to be in a 3D perspective. Obviously, blank scene, create a new one. Then obviously you have your animation here. So let me just enlarge that. Let's make it bigger. So make it bigger. So obviously you have your normal ArcMap in behind, so it doesn't close that. So if you want to visualize your digital elevation model, because if you actually go back to this particular your ArcMap, it's actually in 2D format, so it's not easy to actually see it in an actual 3D perspective. ArcScene actually allows you to see it in a different heights from a 3D point of view. So to do that, you add your data, and we actually want to add our digital elevation model for Johannesburg, so GHB DEM. And then what we're going to do, so as you can see, my mouse pointer has even changed almost to a 3D aspect, so I can actually rotate. If I hold my left click, I can actually see it from a 3D perspective. So those that are used to AutoCAD, you can actually see this. So let me just zoom back to that layer to see how it is. So this is what ArcMap Scene enables you to do. So while I'm at that, let me also add the actual Johannesburg shapefile. So let me do this. Let me close that. Come to my catalog, and then look for my Johannesburg SHG. I've gone a bit blind for a second here. Yeah, it is. Okay, so I'll talk about this later on. For now, I'll just switch off that layer. So now we're going to actually project this particular elevation model into a 3D perspective. So to do that, come to your Johannesburg DM, double click, then come to your base heights. Then under base heights, you obviously have your elevation from surface, no elevation, and you're floating on a custom surface. So basically, what we're going to tell the software to do is actually extrude, or in essence, to extrude the actual 2D shape based on the height data from the digital elevation model. So basically you can extrude it to a custom of 1 point, or you can extrude it to a custom of. So if I change it to 3 and I click OK, wait for that to load. Then if I just almost scroll from a side perspective, you can see it's actually starting to show where the high points of elevation and where the low points of elevation. So this is to an exponent of 3. Let's actually do it to exponent of 10 to get a better visual aspect. If I do that, then I click OK, and then if I come to my side, this gives you a better visual aspect in terms of the actual terrain of the city of Johannesburg. So as you can see, particularly to the northeastern, northwestern quadrant, that's where the actual lowest point of the city of Johannesburg is. Then obviously along your mining path, that's where you have your more mountainous areas. So obviously when rain occurs, water obviously descends to the lowest point and gathers at the lowest point because it's under the influence of gravity. So essentially when flooding occurs, it would actually occur from this perspective, from this point, this is the actual lowest point, and it would actually gradually rise across. So remember I mentioned about the river banks, how river banks are situated. This is how actually the city of Johannesburg's actual terrain is actually situated, almost similar to a river bank. Obviously, this is a bit exaggerated because I've done it to exponent of 10, but just to give you a bit of a perspective in terms of the terrain. Then as you come right to the middle, you actually have your mining belt, and this is where your mountainous areas are. So these areas are actually the areas that are most susceptible to landslides. And as you can see, these particular areas here on the banks, are these where there's a sharp gradient in terms of the slope. These are also the areas that are more susceptible to also landslides as well. So let me change the color scheme. Change it to more color scheme that's more applicable. Change that. Okay, and yeah. So based on that color scheme, based on that color ramp, you can actually give a better visual aspect in terms of which areas are most prone to flooding. Obviously marked in your bluish color, and then which areas, in obviously vice versa, that are susceptible to landslides are marked in your height color of white, descending down to a brown and orange. So you get a good visual aspect of this. So you can actually export this, and you can use it as part of your write-up in regards to validating or justifying your commentary on question 5 in terms of which areas are most applicable to flooding, which areas are most applicable to landslides. So this is the power of actually ArcMap scene. It helps us to project digital elevation models, or even shape files that have in its attribute table information about its actual height, the Z value, and also the X and Y value. You can actually use that in ArcScene, which can actually project the actual shape files into 3D perspective. So now with that second part done, now I'm going to show another bonus feature. So for those that maybe they want to so let's say if you want to actually simulate flooding. So if actually rain had to occur, where would flooding actually occur first? So I'm going to drop this back to, an exponent of space height. So I'm going to drop it back to exponent of 3. Okay. Obviously, that shows quite accurately where areas are going to be. So now, moving on to basically we're going to move on to the simulating of flooding in Johannesburg. So we're going to come back to this file that we first did. So I know it's going to be a bit technically in terms of the wording, be a bit difficult, but if you just follow, you'll see essentially what I'm trying to convey across. So what I'm going to do is actually change the color. So this Johannesburg is actually going to represent the base water. So that will represent the base water. Then I'm going to change it. I'm actually going to change the name so it's a bit easier for you to remember. So I'll change that to base water. So this will actually be as the actual water. Then now we're going to go to our animation scene. You're going to right click on your ribbon at the top and click on your 3D animation. So you can just pop it there, and then come to animation manager, and now we're going to actually add the time keyframe. So basically we're going to add the time keyframes for our base water to actually rise. So I'm going to come to create, obviously there, new keyframe 1. Then because we've done it to exponent of 3, our lowest point is 1002, so we might have to times that by almost 3 in a sense. So let's do this. I'm going to create, 10. How many keyframes do I have? 9. Okay, another one. Let's create 10 of them. And then now we're gonna add actual the translation height value. You're gonna actually add that there. So this might take a few try and errors to get it right, but let's just see how it appears. So what you can actually do is actually you can get out your calculator, which would actually help with getting this right the first time. So I'm just getting my calculator out. Okay, so obviously our first value is 1281, so we're going to say 1281 times by 3. This gives you 3843. 3843 there. Close. This was, let's play around with it. Let's just see if it's actually gonna appear. I'm gonna come to my play animation, click play, and see where it starts. So it starts correctly there. That's fine. Obviously times it by 3. So let's come back to our animation, come back to animation manager, 38343. So I'm actually gonna start to add 3850. And I'm gonna actually go up in intervals of 50. So let's go 3890. Let's go by 3. Sorry, this would be actually 38. Yeah, so already 8900. And then this should be 3950. This should be around 4000. This should be 4050. This should be 4100. This is be 4150. Be 4250. I just find it up a bit higher. Let's go. This should be 4300. 00. 4350. And our last two keyframes 0. And we can close. And then let's play our animation. So come to open animation controls and let's change the duration options to seconds. So sometimes this might take a bit of trial and error just to see if it appears. Then click on play and let's see what happens. So 20%. Then as you can see, the actual flooding will actually start occurring, like I said, in that particular quadrant. So this is your area that will first be affected by flooding, as you can see from the animation. So basically, if you're going to just repair that again, so if flooding had to occur, the first areas that will be affected are this quadrant here, because of its actual terrain structure and its also elevation. If flooding will first occur, then obviously flooding will start appearing on these sides here as well. So as you can see, this is the path arc scene where you can actually start visualizing where you're actually not visualizing but actually simulating flood events, which areas are most likely to be affected. So to better enhance it, to see how to go further, let's come back to our animation. Let's go back to our animation manager and let's actually add some more some more keyframes. Let's go up to 23. Let's go up to 23. And then adding those numbers. So let's go at 4500. Let's go at 4600. So I'm skipping a few 50s, but that's fine. 4650. 47 plus 100, 4750, 100, 850. I'm not doing a bit of an overkill. Obviously 5,000. So the reason why, obviously the height started at 1,281. The reason why I didn't start, at that height is because I made the DM to extrude by a factor of 3. So automatically I must times 1,280 by 3 to get the proper correct number. So it's in alignment, so it doesn't start all the way at the bottom. So let's try at now at 500, 505. Oh, I can click on that. See, and maybe let me change the color of this. So it's a bit more. What do you get here in terms of this? The simulation. And then let's play our animation and see how it goes. Obviously 20 seconds. And as you can see, that's where flooding will first start occurring. Right there. That would be the first contact point. And obviously that second, third. So obviously the areas to the south then start flooding. And as you can see, the highest area will be the last area to actually suffer from flooding. Let's get it again. Let's see the quadrant. So those areas most applicable that will suffer from flooding. And then become worse. So obviously because the digital elevation model is only at 90 meters, if we had a better resolution, it could actually simulate maybe particular areas that actually see flooding first. So each area is also a bit different. So this simulation is accurate to a certain degree, because some areas will actually have a river basin, or actually basin, a localized basin. They create flooding there. So this simulation is accurate to a certain degree, not 100%, but gives a good illustration of how flooding will occur. So if you want to export that video, because most likely I think this assignment will be a soft copy submission, just waiting for clarification or confirmation on that. And yeah, so this concludes this part of the assignment. So basically you can actually use this, take screenshots of each segment within the flooding, and you can use that to justify question 5 as part of it as an illustration, which would be quite cool to add. So not a requirement, but something cool to add, even to apply to your general professional work streams, for those that are working in maybe the environmental department and so on. So that concludes assignment 8. I hope it is clear. Thank you guys. Please like, subscribe, and I hope you enjoy.